Welcome to the Bentley Systems training course to learn how to design concrete building structures in Staadpro. Over the next series of videos, we will show you a typical workflow for designing concrete building structures, which will include the process for creating load combinations and load envelopes. We will show you how to perform a P-delta analysis, and we will show you how to design concrete beams, columns, and slabs using the Reinforced Concrete Designer within Staadpro. After you have created your concrete building structure in Staadpro and provided all of the gravity and lateral load cases that will be necessary for your building design, you are then ready to generate your load combinations. Staadpro offers two options for generating your load combinations. You can create them manually, or you can create them automatically using a variety of building codes, including the American Concrete Institute code. When generating your load combinations through Staadpro, you have two different options. You can generate traditional standard load combinations, or you can generate repeat load cases. In a traditional load combination, Staadpro would analyze the model and then algebraically combine the results of each of the load cases in that load combination. If you are planning to perform a P-delta analysis, it's important to generate repeat load cases instead of your traditional load combination. The repeat load option, in contrast, will instruct Staadpro to consider the load cases acting concurrently before the analysis is performed with all of the necessary load factors applied to them. For this training, we will be designing the concrete beams, columns, and slabs for a concrete structure that has already been created in Staadpro. All of the model geometry is complete and all of the necessary properties have been defined. In addition, if we select the General tab and the Load and Definition sub-tab, and then we could expand the load case details, we would see that several load cases, including dead load, live, wind, and seismic, have already been created. We are now ready to generate the load combinations according to the ACI 318 Concrete Building Code. When you are ready to generate your load combinations, we would need to go to the Load and Definition dialog and highlight the Load Case Details option. We would then go and click on the Add button, which will automatically bring us to the Add New Load Cases dialog. From this dialog, we can define manual load combinations or use one of the load combination generators available in Staadpro. For this training, we are going to use one of the auto load combination generators, so I'll select the auto load combination option. From here, I could select my load combination code, and I'm going to select an ACI code option, and I'm going to keep that set to table number 1. In addition, for this particular model, I am going to be performing a P-delta analysis, so it is important that I select this checkbox to create repeat load cases. Once I've specified all the appropriate parameters, I can just click on the Generate Loads button, and now all of my load combinations have been created using the load cases that I've already defined. Once I'm complete with this process, I would click Add to officially add the load combinations, and then once that process is finished, I could click Close. Now I can see that all of the repeat load cases have now been created. In addition to generating our load combinations, we can also use the Load and Definition dialog to create a load envelope. Load envelopes are groups of load cases set under a single moniker. Now for this model, we are preparing to design the beams, columns, and slabs in the Reinforced Concrete Designer within Staadpro, and the load envelopes will be used for the design of concrete beams and slabs. So when doing this type of workflow for your beams and slabs in conjunction with the RC Designer, it's important to create some load envelopes as well. In the Load and Definition dialog, I will scroll down to the end and I can see an option for load envelopes. I'm going to highlight it and then go ahead and click Add. Now here I can create several different types of load envelopes, or I can set the type to none, and then I can grab whatever load cases or combinations that I'm going to want included in the design of those concrete beams and slab elements. For this particular model, I'm going to select all of my repeat load cases per the ACI code. So I'm going to highlight the first one, which is load case number 7. I'm going to scroll down to the end of my load combinations, hold down my Shift and Control key, and then click on load combination 37. That's going to select everything that was within that range. I could then use these arrow buttons to move something from the available window over to the selected window. And I'm going to click on this single right-hand arrow, and this will grab all of my highlighted load cases, which happen to be all of my ACI load combinations, and move them over to the load envelope definition. Once you've completed that step, go ahead and click Add, followed by Close. And if I expand this load envelopes group, I can see that now I have an envelope available, and this will be available once I get over to the Reinforced Concrete Designer. The last step before analyzing the model is to specify your analysis type. And for this training today, we're going to be performing a p-delta analysis. When performing a p-delta analysis, you can include the effects of both the large p-delta effect and the small p-delta effect. Of course, our large p-delta effect is our second-order effects induced on a structure due to the movements of its mass under lateral loads. When we're talking about your small p-delta effects, these would be your second-order effects caused by displacement of the member between the brace points. To define your p-delta analysis, I'm going to go over to my page control area and select the Analysis Print tab, and the Analysis sub-tab is going to be selected by default. In the Analysis Print Commands dialog, I'm going to select the Perform p-delta Analysis tab, and here I have several options to include your small p-delta effect, your geometric stiffness, and the number of iterations I want to use. At this point, I'm going to define my p-delta analysis, and then click Add, which will enter that command at the end of this analysis dialog. I can then go ahead and click Close, and if I scroll all the way down, I can see that a p-delta analysis has been defined. Let's also scroll up a little further in our analysis dialog. Here I can see that a p-delta analysis and a change command has been added after each of my IBC seismic load cases. This will instruct Staadpro to analyze each load case individually and then reset the stiffness matrix before analyzing the next load case. And this would be a requirement for defining any IBC seismic loads. Whenever you do have an analysis command, though, after creating a load case and before additional information is added, you should also use your setNL command. This will be used to specify the maximum number of primary load cases for processing, and it is used in a multiple analysis run when more primary load cases are added after an analysis has been performed. To define your setNL command, I'm going to go up to my Commands menu item. I'm going to select Miscellaneous, and then I'm going to set this setNL option. Here I can set the maximum number of loads, and what I'd want to do is set it close to the number of load cases that I have in my model. So for this particular model, I'm going to set this at 100, and I know that this is greater than the number of load combinations and load cases that I have. I can then click OK, and I've completed that step. At this point, we are now ready to perform the analysis on the model and enter the Reinforced Concrete Designer. To perform an analysis, I'm going to go up to my menu bar and select Analyze, followed by Run Analysis. And I am going to save the model before continuing. After the analysis is completed, I have the option to go directly to the output file or the post-processor, or I can stay in the modeling mode. For this training, I'm going to stay in the modeling mode and then click Done. After performing the analysis, you will now be able to enter the Reinforced Concrete Designer within Staadpro. The Reinforced Concrete Designer is a design module that is integrated with Staadpro. It'll use the geometry and analysis results from the model that we have right now, and is able to design concrete beams, columns, and slabs according to several concrete design standards. And you can only enter the RC Designer once an analysis has been performed. To enter the Reinforced Concrete Designer, I'm going to go up to my menu bar, select Mode, Interactive Designs, followed by the Concrete Design option. In Staadpro, the Reinforced Concrete Designer is a design module that is integrated with Staadpro. It'll use the geometry and analysis results from Staadpro, but then it allows for further definition of concrete physical members, and it produces designs accordingly. The first step in our workflow once we get to the Reinforced Concrete Designer is to form our physical members and slab objects. Staadpro defines beam members as line elements connecting nodes. To correctly model the connection between the filler beams and the girders, the girder members must also be connected to the nodes at the ends of the filler beams. As a result, the girders must be divided into separate members spanning between the end nodes of the filler beams, and Staadpro refers to these separate members as analytical members. In the actual structure, however, the girders are single members spanning between columns, and those are referred to as physical members. Staadpro does provide for the grouping of individual analytical members into physical members using a special member group called P-member. In order to form a physical member from a group of analytical members, the analytical members must be interconnected and collinear, and the local axis of the individual analytical members comprising the physical members must be identical. In the RC Designer, designs of beams are performed on physical members, which are made up of one or more analytical parts. Physical members can be created manually by using the Form Member command, or automatically using the Auto Form Member command. Similarly, when you model a slab in the Staadpro modeling mode, we would typically generate a group of finite slab elements, as you can see from the sample structure on your screen. In the RC Designer, however, designs of slabs should be performed on slab objects, which are made up of one or more finite elements. Slab objects can also be created in the RC Designer using the Form Slab command. To create our physical members in the RC Designer, we will go over to the Page Control area and click on the Members sub-tab. From here, I want to select all of my analytical members, and I can do that using my Elements cursor. Once you've selected all the members in your model, I have two different options. I have a Form Member command and the Auto Form Member command. Since I selected the entire model, the Auto Form Member command would be more applicable. Now I can see that several physical members have been created. If I want to select a physical member, I can use my Member cursor, and then I can see how my physical members were created in my model. To form slab objects, I would return to my Page Control area and select the Slabs sub-tab. Here I'm going to create a single slab object for this entire area. So again, I'm going to use my Select Plates cursor and fence around the entire model, which will select all of these finite plate elements. Then if I wish to form a slab, I can go ahead and click on the Form Slab icon to create that slab element. Again, I have a cursor available to select my slabs that I created, and here I can see that one slab object is covering this entire area. Now, a typical workflow once we get into the RC Designer would be to start at the top of this Page Control area and work our way down. So our load envelopes have been created, physical members have been created, and also our slab objects. We are now ready to move on to the next phase, which will be designing concrete beams, columns, and slabs.